Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the Faculty of Mechanical Engineering. Today we are going to have a very quick virtual tour, whether it is physical for me of FME, and let's see how we teach our students and how we skill them for coming into the industry. So let's move on. First of all, I will show you that we are the only faculty in Pakistan which is ISO 2001-15 certified. So if you see there, yes. So we are the only faculty in Pakistan which is 2015 certified. And you can see some parts of the engine, aircraft engine there, some parts of the suspension system there, and there are many demonstrative models available where students can see and understand things. So let's get inside. So first of all, this is the main area of FME when you enter the main gate, and here you can see the main distribution of all the rooms and labs. So in today's tour, what we will do, we will go to the ground floor first, and we will see some of the labs. For example, we will start from the workshop, then we will go to CNC training and industrial lab. Then we will move on, we will go to Nfrc Lab, Computational Lab. There are some of the labs which will be exempted because of the shortage of the time or not to make you bored. So the important features of the lab will be shown there. After the ground floor, we will go to the mezzanine floor, which is before the first floor, and there we will see one of the lecture halls. We will go to the main lecture hall and I'll show you how the students sit there and get a deep education. And after that, we will go to the other labs which are available in the first floor. And at the end, we will get out and we'll talk little about the other features and facilities available in GIK. So let's move on. Let's start from the workshop. You can also see that around the workshop or around this lobby area, we have different posters of the students. So these are different projects made by students there, their final year. And when they present that project, they after that presentation is completed, they are mounted on that wall. And we can use that for the people who are visiting there and understand. So when we move here, all around the walls, you see that there are many posters all around the balcony, on the ground floor and on the first floor. So let's start with the workshop. So let's enter workshop. Come on. Be careful with the stairs while entering the workshop. So here is the workshop area. Workshop area has its own safety requirements and safety gears, so you must enter them with your safety requirements. So let's move on. I'll go on with the safety equipment first. So let me wear this first. So in order to avoid myself from any hazards. And I have to speak and I'm maintaining the distance, so I'm not taking the mask. But just to be safe from the hazards and things around. Let's move on. So you can see around here we have a different types of machines. This is the bench work in the beginning, and then we have the lathe work here. So if we keep on moving away further. So this is the lathe area where the students learn their turning and similar jobs. And also we have the technicians who help them here and they work there. And if we move on to the lathe area, so at the moment there is no job available on the lathe. There are many different machines here. So this workshop area helps out for the different machining facilities available for the training of the students, and also it uses our facility for developing projects related to the projects made by students, fundings and all related stuff. So this workshop is quite handy, and not only FME but all over the GIK, all over the institute, people come here for their projects. Even outside GIK, the industry gives their problems here and we solve the projects here. So let's move on to the next place. Okay, so moving on, let's move to the next lab. And this is your composite lab. The composite is a very state-of-the-art lab which is required these days because all the materials, all the journal stuff which was made by metals now is being replaced by composites. So this is a small composites area where we are working here. So if you come here, we have the upper plate, we have some safety area here, and this is sort of an oven for curing the composites with the required pressure and all the requirements which are required for the composites. So that is a very good equipment. And here is the layup area. So with your safety gears and everything, you can make the composites. So this is a very good facility we have here to make things which are made from the composites. So let's move on. Let's move on to the next lab. We go out of the workshop. Okay, so the workshop is completed. So let's go to the other labs. We go on and move on to the other labs of the FME. Okay, so now we will move towards this corridor. So our labs are situated in these lobby areas on the right and left side. So here we have the CNC training, the CNC industrial, Nfrc, and computational lab. And at the end we have the emergency exit. So let's move to the advanced manufacturing processes lab first. So come on, towards right you will get your manufacturing processes lab. Let's enter it. Okay, so here is the advanced manufacturing processes lab, and we have very state-of-the-art manufacturing processes here. For example, if you come here, you see we have different turning centers. We have different machines which are related to both. All these are related to the turning. They are vertical millings, and then we have also developed some in-house indigenous machines which are on the verge of commercialization. For example, here you see they are prototypes, they are proof of concepts for Revolut robots, they are manufacturing milling machines, there are many stuff is in the process. Okay, so that's our advanced manufacturing processes lab, which is not only doing the jobs for others, but many other prototypes for the new machinery are being produced here. So that is our advanced manufacturing processes lab. So let's move to the next lab. Okay, so this is our industrial CNC. So in the last lab, most of the things were used for making new manufacturing machines. But this lab is a general purpose lab which has its own facilities. They are different from the other one. So come on. Okay, as we enter here, here we have the CNC lathe. So this machine was recently refurbished by us. That is used for many CNC jobs related to lathe work. And then if we move on, there are some other manufacturing processes lab. Here, for example, we have the laser cutting wire cut machine. So wire cut machine is used for very precise machining. And similarly, if we come here, so the technician is working on. This is the vertical milling. So these are all CNC machines which are used for their own specific jobs. And the last but not the least, we have here our 3D printer facility. So we have two types of printers here. This one is a typical hobby type, but this one, the last one, it is a dual laser and it has a very wide range of temperatures. So you can see that this is a 3D printer which can be used for diverse type of additive manufacturing products. So basically, mostly it is based on the polymer. So you can see some of the jobs made by it. So this is one of the latest facilities we have for advanced manufacturing processes. So that's all for the manufacturing processes. Let's move to the other stream of the FME. Okay, so we have the Nfrc Lab here, the Natural Fluids Refrigeration Center. So this is the unique lab of its type in Pakistan. That is a collaborative lab made by University of USA and GIK. So in this lab, you can see we have the a heat exchanger which is based on natural fluids. So mostly it is using ammonia as a working fluid. So it is one of its specific unique type in Pakistan. You can see through. It has its compressor, receiver, the exchanger, and the sink, hot water tank, all this stuff there. So that is the specific lab for graduates. So the other labs I have been showing you, they are used for both undergraduate and graduate projects. We will move on further and we'll see some other labs which are used by the students. So this is our Computational Mechanics lab. So all of our courses which are whether related to thermofluids or mechanics or manufacturing processes, all courses or vibration or dynamic system control, all have some tools which are related to the computer. So in this lab we will tackle those things. So this is a pure computer based lab. It has good quality latest computers available, good I-series computers are available here, and we have state of the art licensed software available in FME. For example, here if you see we have the MATLAB here. So other than MATLAB, we have Preview for modeling, SolidWorks, we are in the phase of purchasing, and then we are using the MSc Complete suite. We have MSc1 which relates to MSc Add-on, CFD, Cradle. We have a perpetual license of ANSYS, and we are also we have limited version of Lab. So we have all very market in software available in FME, where students can learn and get skilled, and when they are out of the university, these tools and software are very useful for their future career. So that's for the competition lab. So let's move on to the next lab. Okay, so most of the labs which have the particles or moving machinery, we use the safety code. Otherwise, in other labs, it's not required. So in the coming labs, mostly it is not required. So let's move to the next corridor. And here we have our labs related to heat transfer, heat engine fluid mechanics. So let's go and see them. So first of all, we have the Mechatronics Design Lab. So let's enter the Mechatronics Design Lab. So in this lab, we have purely electronic related or mechatronics related here. The most important and famous will be the teaching facilities related to robotics. So we have different type of commercial robots here. There are also some robots which are developed by students, but here what you see are the commercial ones. Okay, so this part is related to robotics. On one side of this lab, we have a very good equipment related to wind tunnel as well. So that was designed for wind tunnel, so that portion is related to wind tunnel. It is a very specific supersonic wind tunnel of its type. It is a small area, but it is still useful. And it was started with by some students, and it was developed by and refurbished by different series of students. So it has part commercial, part developed by indigenously by the students. So that was the Mechatronics Lab and our supersonic wind tunnel. We have another wind tunnel which is on the top floor, the first floor. We'll go and we'll see it later. So let's move on. Let's move on to the next lab. Okay, so the next lab we have is heat transfer and refrigeration lab. So in this lab, our graduate and undergraduate students conduct labs related to refrigeration and heat related to heat transfer. So come on, let's see further. There are some students working on their projects, on their research projects. Some students are related to their undergraduate work, some are related to their graduate work. So let's see some of the apparatus here. For example, here we have apparatus related to boiling, which is used for the heat transfer. Similarly, we have a condensation unit. If you see here, we have apparatus related to heat conduction, which is used for the mode of temperature transfer between solids, among solids. Then we have another conductivity apparatus related to the fluids, specifically gases and liquids. Both, yes. Okay, so here we have a heat exchanger. We have different type of demonstrative heat exchanger for the students to work. So we have different types of shell and tube, plate heat, concentric. There are some other projects. So here we have a project by a graduate student. Will you explain your project? What are you doing here?
Yeah, it's actually a heat exchanger that works on the gravitational water bodies.
Okay, so this is a gravitational heat exchanger which works with the flow, with the whirling action of the whirling fluid, and it has its own performance and efficiency. So moving on, we have some other apparatus which are on the other side of the row. So let's go there and see what are they. So for example, here we have some portion related to the refrigeration. So this is a demonstrative trainer for vapor compression cycle, the refrigerator we see in our homes. from inside it has this structure which is very well explained here. So it has its own different units there. It has its own evaporator, condenser, compressor, all the stuff here. So this is another one. It is the same type of unit, but it has its own different properties. Then we have a different type of compression cycle, that is absorption cycle. This unit is the demonstrative unit or trainer for that absorption cycle. Here we have a unit for demonstrative purposes of air conditioning. It is a closed cycle air conditioning, so the air enters from one side and keeps on circulating in the same cycle, going through different phases. And there's another one, it takes air from one side and gives it out, and between the flow it has its own refrigeration or air conditioning. So the air is conditioned while moving through the passage, and then it goes out. So it is an open cycle. Final year projects made by students are also used here. So the concept here is to utilize students to develop something. Buying something from the market and using it all together is very easy. But when we employ our students to work on something and they develop themselves something, it really means a lot. And when you do something with your own hands, it really defines the meaning of hands-on training and hands-on learning. So when a student has developed this type of heat exchanger or aerodynamic structure, he can well understand what is the process going on. And in the future, it is very important for his career development. So that's all for the refrigeration and heat transfer lab. So let's move on to the next one. So this is heat engine lab. So let's move on to the heat engine. So there is the safety exit as well. So if there is an emergency, you can go out of it. Otherwise, enter the lab. So this is a heat engine lab where we have different types of heat engines and we either test them or demonstrate them. So for example, if I start from here, we have steam, a demonstrative unit of steam power plant. Okay, and then we have the air compressor set, so the compression processes are studied here. Similarly, we have another unit which is used for the gas turbine. So it's a two-shaft gas turbine demonstrative unit. Here on the side, we have a laser engraving machine, so the students can do some manufacturing processes here related to the laser engraving. So it was related to the lab in charge of this lab, so that's why it's placed here. So laser engraving machine has its own uses, which is used for developing different structures or models which are used for fluid dynamic experiments or any other related stuff. So let's move on to the next thing. Here we have a demonstrative engine tester. So Asim Saab is working on it. So it's a very specific type of single cylinder test bed here. So he has been working on it and he's still maintaining it. So that's all for our lab. So also we have some demonstrative units, like if you see, this is a demonstrative unit of a car model, car transmission system, which is related to its gear, its clutch. So the car from inside is something like that. Okay. So when you transmit something, you push the clutch and you change the gear, and after changing the gear, you have your clutch here, and then you have the engine. You can see the cylinder, the piston. So everything is open and transparent. You can see how the fuel injects, how the transmission is working, how the power is being converted. So you can see this is the camshaft. These are the valves. This is the cylinder. This is the piston. It has its crankshaft. So all that stuff is demonstrative purpose. So when the teacher is teaching here, everything is not virtual. These are the physical things which are available here. Okay. So that's all for the heat engine. And let's move to our next lab. Okay, so this is the fluid mechanics lab, the last lab we have on our ground floor. So let's move on and see what's going on in the fluid mechanics lab. So in the fluid mechanics lab, there are many experiments performed by the undergraduate students on the fluids. So for example, here we have a multi-turbine test ring. So it has different types of turbines, and we see their performance by running one of each of them. Similarly, we have a large number of hydraulic ventils here. So here, for example, We have another multi-pump test bench which has every hydraulic bench has a motor and a compressor which keeps a fluid moving on. Most of the time that fluid is water. Okay, so technicians are working here on their work. Similarly, we have friction flow apparatus. So different type of flows when they have different type of inclusions inside them, they have different drops. So this friction apparatus is explaining those things. So all of the lab is filled with hydraulic benches most of the time, and some other projects are also there. So for example, this project, this is a piping research. Okay. So this is a project made by the students. Yeah. So it's a very good brainchild of Dr. Asif. So that was a membrane distillation plant. That is something which is very important for Pakistan point of view, where you want to have clean water for drinking. So that is a demonstrative project made by students in their final year project. So this is most of the projects I've shown here. Similarly, we have orifice and jet apparatus here. We have the Reynolds apparatus here. So all of the apparatus, whether they are explaining some application, some usage, or they are telling you about some principle which is made by the fluid dynamics. So that's all for fluid dynamics. Let's move on and let's move to the next slide. Okay, so now we have reached our mezzanine floor, and as I told you, I will show you some lecture hall where the students take the lectures. So let's enter and see how the classes are arranged by students. So this is our main lecture hall here. So if you see around, so there all the students sit there and take their lectures. When they have, and some lecture way of studying is there, the lab is not there. We have our whiteboard. We have our display center for the projector. So if something is to be shown by the computer and the projector, the students are shown that. We have an additional whiteboard here, so the students can have more view, because when they are sitting around, some part of the whiteboard is not clear for them. So it is convenient for the teacher to use different boards. And during this COVID area, we have a big rooms here where students can sit while maintaining their safe distance and having their own safety gears with them. So it is fully air conditioned, all the light conditions are very perfect. So the teacher, based on his requirements, changes the light, switches some on, some off, and it is centrally air conditioned lecture halls. And if the sound is the problem, we have our multimedia system as well. So no problem with the sound system. We have the mics. So every gadget or facility is available here to make the student understand in the best possible way. So that is our teaching room. We have similar lecture halls. We have 3 to 4 lecture halls for FME. Same goes for every faculty. This one is the largest one. Similarly, the other ones have the same facilities there. And all the labs and courses are scheduled in a way that all students can be accommodated easily. Conventionally, the classes are in the morning till midday, and in the afternoon we have our labs. So after the students come from their lunch break or from their prayer break, they come back and they conduct labs. So that was related to our academic process and labs, and that was one of the mezzanine floor. So let's move further up, the first floor, where we will see the rest of the labs. Come on. So, okay. So this is the first floor of FME. So let's start from the right side and we'll see what are the other labs which are remaining and we need to show you. So again, the models, the posters of the students is still on. We have some other additional rooms, like we have the drawing and quiz hall here. So the students can conduct drawing or they do their quizzes here. I will explain later how the quizzes are scheduled. And then this is another very important lab of FME, that is vibration and control systems. So let's enter and see what's in that lab. So here, in this lab, we have two main works going on. One is the control systems, and one application field of control system is the vibration. So vibration is mostly used for understanding the controls, and the portion of the vibration separately is also there. So we can have a look on some of the apparatuses. For example, if you come here, This is the hydraulic system which is related to fluids, but control systems are used to control it, automate it. Okay, so if you move further, we have another prototype here for the quadcopter. So that is a project related to stabilizing the quadcopter, to develop the controller for the quadcopters where they can self-stabilize. Similarly, we have some projects which are for lab apparatus which are demonstrative, some are for training, some are used for research where the students are working on their research. Okay, so if we go on, we can see some of the apparatus related to vibration. So if you come over here, for example, we have a vibration system here. It's a cantilever demonstrative system, cantilever beam, 1 degree of freedom. Similarly, we have this system used for the damping. Okay, so the damping coefficient can be found for different lubricant oils. There's another very important apparatus related to walling of shafts. So that is related to the balancing of moving parts, the dynamic balancing. Similarly, like the technician is working on the static and dynamic balancing of a shaft. So this is a demonstrative project. Also, similar shafts can be tested for the balancing here. Okay, so this vibration and control system lab is carrying on different diverse projects related to the research and industrial support. So that's all for the vibration and control lab. So let's move on and go to the next one. Okay, so now the next lab is the solid mechanics lab. Apparently it's solid mechanics, but it has also some other labs connected with it. So let's enter and see what's inside. Okay, so in this lab we have different subjects, basic subjects related to the design or mechanics field. So for example, the first lab, which is the basic one, is the statics lab. So where we perform different demonstrative or procedural types of apparatus used by students. Like we have the disc brake, the driving torque valve. So they are very basic and commonly used static apparatus here. Similarly, we have the theory of machines lab here. So we can have different apparatus related to the theory of machines, and the mechanics of solids, where we have different apparatus related to the mechanics of solids. Some of the apparatus are here, but many other apparatus are available in the store. So as and when they are required, they are taken out. So this is a very specific type of compressor which is used as the aid for different apparatus. So here we have the thin cylinder apparatus where there are strain gauges mounted on it, and we can see the deformation when the pressure is built inside. So this is a manometer for building pressure, and the compressor I showed you was used for the pressure building. So this is one apparatus. These are some stuff related to the theory of machines. So this main lab, which is bigger one, has many apparatus because these apparatus are small, so they don't need a lot of space. So that's why we have combined many labs here. So this is a beam deflection apparatus for defense. So that's all for our mechanics of solid lab, which is a basic lab which is used for the other advanced labs. So let's move on to the next lab. Okay, so let's move on to the wind tunnel. I told you that it is on the first floor. So that is a unique wind tunnel of its type in Pakistan. So you see from starting from here to here, it's very large wind tunnel. So if I tell you how this wind tunnel works, so this is a apparatus used for measuring lift and drag forces. So it can calculate the static and dynamic pressures, and it has its own different coordinate system to measure the drag and lift forces in different directions. So if I see the area, it has a length of 122 centimeter and width of 61 centimeter and height of 61. It's quite big, and we can have different ranges of speeds. There can be small changes in the ranges specified. So if you see there, this is the working area of this wind tunnel. So this is subsonic wind tunnel, and it is a very big cross-sectional area. Okay, so if let me show you the intake of this. It's quite big. So if you see here, this is the place where the air comes and goes inside. So you can see a lot of honeycomb cross sections here. It's quite big. If you see, it's quite big cross section area. So this is the intake area, and if I show you the exit, so air enters here, goes through the thing which is being tested. Then this is a divergent nozzle, and here we have the exit. So here comes air comes out of it. So when the air reaches here, the velocity is decreased a lot. So this is how the wind tunnel works, and we use this wind tunnel for the undergraduate aerodynamics experiments. We also use it for the graduate research, and some other industrial projects are also conducted here in this lab. So this was our wind tunnel. So let's move on. Okay, so we have seen most of the part of FME, and in this working environment, if you get bored or to have a sustainable ambience and greenery around, we have a beautiful garden of FME here. So if you look around, we have a grassy garden with very well built old trees here. So as I've told you, I've shown you different labs here. Basically, Faculty of Mechanical Engineering, which is commonly known as FME here, is divided into 3 to 4 thrust areas. So these are design and manufacturing, Thermo-Fluids, system dynamics and control, computational mechanics. Every lab which you were watching was directly or indirectly connected to some thrust area. And when we were, for example, we saw the refrigeration lab, the fluid dynamics lab, that is related to thermofluids. You saw solid mechanics lab, you saw the manufacturing processes lab, that is related to design and manufacturing stream. Then you saw the vibration and control labs or mechatronics lab, that is related to the control systems stream. And then when you saw the PC lab or the computational lab, that is a lab which connects all different streams together. So the computational work on all these streams is connected here. So these thrust areas are the main focus areas in FME. They work collaboratively for producing graduates which are useful for the industry, and every faculty member with his own strength tries to contribute to his thrust area and publishes and conducts research and publishes it in international scientific community. And at the end, I will also talk about the facilities available here in FME. You saw we take care of all the security and safety measures here. We try to instill the practical and hands-on knowledge to our students. We also try to give them the best environment they can have. I told you in the morning we have our classes, and generally we have in the afternoon our labs conducted. So all the labs are fully populated in the evenings. Today's you saw that most of the labs and classes were empty because this is the currently the summer area and we have the gap. So that is the break period. It was very easy to shoot everything and there was no disturbance around. But if you come after September, all the rooms and labs will be fully populated and all the people will be working here. And in the evening, normally we try to give the time to the students where they can work on their society activity, they can have their social activities there, they can have the sports here. We have the cafeteria, we have the sports complex where they do their different sports activities, societal work. The quizzes and assignments, because this is a complete residential campus, so quizzes and assignments can also be conducted at a convenient time. So we try to complete these quizzes and labs till 5 p.m. Sometimes it so happens because of the companies coming from outside or different courses which has clashes, sometimes students do their academic work in the late evenings, but most of the time it is done in the by 5 p.m., 4 p.m. to 5 p.m., and then they are free to go on their own and do their other activities. So this unique feature is only available here in GIK, that all the teachers, all the staff, all the students are here, and we give them a complete environment, complete learning and research environment there where they are being cured, where they are being prepared for the future career. That's all from my side. We have a couple of things remaining. I'll show you the faculty area here and then we will bid you bye. We have the offices of our faculty members. The dean's office is here, the PhD dean sits here, and also the conference room where all the meetings and official gatherings are there. We have the conference room. So here, if you go inside, we will have the dean office, we have the faculty member offices, the PhD dean office, and the conference room. So this was the administrative section of FME. So here I have given you the whole tour of FME. where you saw how we are conducting research, training, we are doing work on the workshops, we are teaching. All the infrastructure was virtually toured by you, and it's time to exit. So that's all for the day, and we have completed our visit here. So I thank you for watching me, and if you have any questions or queries, problems, you can contact the social media page of FME. You can contact the other social media, not only Facebook but Twitter and LinkedIn. And also we have our contact office from the phone, where you can contact the student section and get the relevant information. So that's all for today. Thank you very much. Bye bye.